How does the power of an engine relate to the driving force that that engine is providing to the car? Let's look at the situation using a diagram. So you have here a car. The engine is providing a driving force, represented here by this vector. There is some friction, obviously, in the road. The car starts at a certain velocity u, and it ends over here with a certain velocity v. As you can see from the diagram, I already represented here the driving force smaller, but you are going to see that this is a consequence of everything that we are going to study. All right? At the end, you are going to see that the driving force is as big as the friction. For the sake of argument, let's imagine that throughout the situation, the car's engine is working at its maximum power, whatever it is. All right? Without knowing any more physics, you already know what happens. If you have a car, if you probably don't drive, but you probably ride a bicycle. If you are doing your maximum power on top of a bicycle, and you continue doing that for some time, what will happen? You are stopped, you start pedaling with your maximum power, and that's the moment where your acceleration is going to be maximum. You are going to speed up very fast. But the more time it passes, and even if you continue pedaling with the top power that your body permits, what is going to happen? You are going to accelerate less and less. You are going to be at a higher speed, but you are not going to be able to speed up as much as you were right at the beginning. Eventually, you are going to continue pedaling at your maximum power, and you are going to notice that the bicycle is not going to move any faster. You have reached your maximum speed. This stems from a very simple equation, which is the equation of power. What is the power? Is basically the work that is being provided to a system, in this case a car, divided by the time. If you studied physics before, you probably already met this expression. Power is energy divided by time. In this case, we're focusing on work, so the power equals the work divided by time. The work done by what? The work done by the driving force. The example I gave was you on top of a bicycle. You also have here the engine of the car. In both situations is the driving force. As you know, the work is calculated by multiplying the force by the displacement. So in this case, it's the driving force, whatever it is, times the displacement divided by the time. Mathematically speaking, it makes sense that you isolate the driving force and you just keep d over t on that side. And what is the displacement divided by time? Is basically the velocity, isn't it? So you can use this expression over here. The power is the driving force times the velocity. So in the example above, if the power exerted by the engine is always at the maximum, or the power on top of the bicycle, an example I gave you, is also the maximum, as a consequence, the car or you are going to speed up. Then at the beginning, when the speed is small, the driving force is going to be big. Don't forget what we are doing, mathematically speaking. This is going to be kept the same throughout. It's the same value. Doesn't matter what it is. It's the same as the part that matters. If this is kept the same, and if these two things are able to vary, then if at the beginning the driving force is big, the speed is going to be small. But if the driving force is big, in this case bigger than the friction, then the car or you are going to speed up. Speed up means what? Means that the V is going up. But if the power is to be kept the same, this cannot go up without this going down, right? If this was also kept the same and this would go up, then the power would go up. But it can't because we are talking about the maximum power, right? So if this goes up, the other one needs to go down, right? So the force, the driving force here is smaller than over here, but the speed is bigger. But this times that is the same as this times that. Eventually, you are going to reach the maximum speed, which is over here, the VC. And VC times the driving force is going to be the same as over here or over there. And what is going to be this driving force? Is going to be just as big as the friction, just enough to keep the car or you moving at the same speed. That's what is explained over here. Okay? It's important for you to know also that the International System Unit for power is the watt. You probably are just going to recall that. 1 watt corresponds to 1 joule per second. All right? I think that in terms of what you need to know, this is pretty much it. Don't forget that this F over here is always the driving force. Note also that what I told you about the maximum power was just for you to understand the importance of this expression. But it works for whatever constant power. I use the maximum because it's simpler for you to visualize that you cannot go put any power above that. But even if the engine is working at whatever power below its maximum power, as long as it's kept the same, the expression can also be used, and all the considerations I just made are also valid. Just this final velocity is not going to be as big as if the maximum power would be used, but the circumstances would be just the same.